The universe is vast and mysterious. It stretches beyond our imagination, filled with wonders that we are only beginning to understand. It's full of stars, planets, and galaxies, each with its own unique characteristics and secrets waiting to be discovered. One of these atoms is carbon. Carbon is unique in its ability to form a vast number of compounds, more than any other element. Carbon is a very special element. It has the ability to bond with many other elements, creating a diverse array of molecules that are essential for life. It's the basis of all life on Earth. Without carbon, the complex molecules that make up living organisms would not exist. Carbon is like a building block. It can form structures as simple as a single molecule or as complex as a living organism. These molecules are the instructions for life. They form the DNA that tells our cells how to function, grow, and reproduce. Without carbon, life as we know it wouldn't exist. Our planet would be a barren, lifeless rock, devoid of the rich diversity of life we see today. Carbon is constantly moving and changing. It cycles through different forms and environments, playing a crucial role in the Earth's ecosystems. As we look to the future, carbon will continue to be a key element in developing new technologies and sustainable solutions. From renewable energy to advanced materials, carbon's versatility will help us build a better world. The universe and carbon are deeply intertwined, and by exploring their mysteries, we can unlock the secrets of life and the cosmos. Together, they tell a story of connection, transformation, and endless possibilities. Carbon is essential for life. It is the fundamental building block of all living organisms, forming the basis of organic chemistry. It forms the backbone of all organic molecules, from the simplest sugars to the most complex proteins and DNA. These molecules are the building blocks of cells, tissues, and organs that make up all living organisms. When living organisms die, they decompose, releasing carbon back into the environment. Some of this carbon goes back into the atmosphere as carbon dioxide, a greenhouse gas that regulates Earth's climate. The rest is stored in the soil or in rocks, eventually becoming fossil fuels like coal, oil, and natural gas. The carbon cycle ensures the continuous availability of this essential element for life. Atoms are energy. Stars are giant balls of hot gas, composed primarily of hydrogen and helium. These celestial bodies are the powerhouses of the universe, illuminating the cosmos with their radiant energy. They're powered by nuclear fusion, a process that occurs in their cores under extreme temperatures and pressures. Fusion is the process of combining lighter elements into heavier ones. In the intense heat of a star's core, hydrogen atoms collide and fuse to form helium. Stars fuse hydrogen into helium, releasing enormous amounts of energy in the process. This energy radiates outward, making the star shine brightly. This energy is what makes stars shine. The light and heat we receive from our own sun are the results of these fusion reactions. As a star ages, it begins to run out of hydrogen in its core. The star then undergoes changes, expanding and cooling, often becoming a red giant. It then starts to fuse helium into heavier elements, including carbon. This stage of fusion is crucial for the creation of many elements essential for life. This process is called stellar nucleosynthesis. Through this process, stars act as cosmic forges, creating elements that are spread throughout the universe. It's how most of the carbon in the universe was created. Carbon, a fundamental building block of life, owes its existence to the life cycles of stars. When massive stars exhaust their nuclear fuel, they explode as supernovae. These cataclysmic events are among the most powerful in the universe. These explosions scatter carbon and other heavy elements into space. The remnants of these supernovae enrich the interstellar medium with the raw materials for new stars and planets. This cosmic dust eventually forms new stars and planets, enriching the universe with the building blocks of life. The cycle of star birth, life, and death continues, ensuring that the universe remains a dynamic and ever-evolving place. Section 5. The Fates of the Universe. The universe is expanding. Scientists believe it began with a Big Bang. The fate of the universe depends on how fast it expands and how much matter it contains. There are several theories about how the universe might end. One theory is the Big Freeze. In this scenario, the universe continues to expand forever. Eventually, stars will burn out and the universe will become cold and dark. Another theory is the Big Crunch. In this scenario, the expansion of the universe slows down and eventually reverses. The universe collapses in on itself in a fiery implosion. Section 6, the Big Freeze. In the Big Freeze scenario, the universe continues to expand indefinitely. As it expands, it cools down. Stars will eventually burn out, leaving behind remnants like white dwarfs, neutron stars, and black holes. Over vast stretches of time, even these objects will decay and disappear. Black holes will evaporate through Hawking radiation. The universe will become a cold, dark, and empty place. In this scenario, carbon atoms would remain intact but scattered throughout the vast and desolate cosmos. Section 7, the Big Crunch. The Big Crunch presents a contrasting fate for the universe. In this scenario, the gravitational pull of all matter in the universe eventually halts the expansion. The expansion reverses, and the universe begins to contract. As the universe shrinks, galaxies would collide, and temperatures would soar. Eventually, everything would collapse into a singularity, an infinitely dense and hot point, mirroring the conditions of the Big Bang. In the Big Crunch, carbon atoms would be subjected to unimaginable heat and pressure, potentially breaking down into their constituent particles. Section 8, the Big Rip. The Big Rip is a more dramatic end-of-universe scenario. In this theory, the expansion of the universe accelerates at an ever-increasing rate. This acceleration is driven by a mysterious force called dark energy. As the expansion accelerates, it would eventually overcome all other forces, including gravity and the electromagnetic force. Galaxies would be ripped apart, followed by stars, planets, and even atoms themselves. In the Big Rip, carbon atoms, along with all other matter, would be torn apart into their fundamental constituents. Section 9. Beyond carbon, fundamental particles. If carbon atoms are destroyed, they break down into their fundamental particles. These are protons, neutrons, and electrons. Protons and neutrons are made up of even smaller particles called quarks. Quarks are held together by the strong nuclear force. Electrons are fundamental particles, meaning they can't be broken down any further. The ultimate fate of these fundamental particles remains a mystery. Some theories suggest that they might decay into even lighter particles. Others propose that they might exist forever. Section 10. The Cosmic Dance of Matter. The destruction of carbon, whether in stars or at the end of the universe, highlights the interconnectedness of all matter. It's a reminder that the universe is dynamic and ever-changing. Atoms are constantly being created and destroyed in a cosmic dance of energy and matter. The carbon in our bodies was once part of stars that exploded billions of years ago. We are all made of stardust. Understanding the fate of carbon helps us grasp the grander cycles of the universe, from the birth and death of stars to the potential end of the cosmos itself. Section 11. Keep exploring. The universe is full of wonders and mysteries. There's so much we still don't know about the fate of carbon and the universe itself. Keep exploring, keep asking questions, and keep marveling at the beauty and complexity of the cosmos. Every new discovery brings us closer to understanding our place in the vast cosmic tapestry. The journey of scientific exploration is never ending, and the wonders of the universe are waiting to be unveiled.